Okay, let's talk about the power rule. The power rule, understand, is a shortcut rule for finding a derivative. So we no longer need to use the formal definition of a derivative, also known as that difference quotient definition. So if you're just in need of a derivative, you definitely want to use these shortcut rules. We're going to see after the power rule that there is a product and a quotient rule, as well as some fancy rules for some special functions. But for now, we're looking at the power rule, which says when we take the derivative of x to some power, the power we are calling n, the result is, well, we get to multiply that power n down, we keep the base x as is, and then we subtract 1 to the power. So the bottom line is multiply down and then subtract 1 to the power. Let's jot that down. Okay? And again, this is only applicable when we have x raised to some power n. Okay? So x is always our base. Alright, so we have an example here. We have the function y equals blah blah blah. We're looking to find dy dx, so our derivative. So we're simply going to multiply down. If there is a number in front, then you're simply going to just multiply down to that number in front. So we would have 24x to the third minus 12x to the negative 4. Okay, remember you're subtracting 1, so if it's a negative, you're going further into negative territory. Now this linear term 2x, that x really has a power of 1, so if we were to multiply down, we would have 2x to the 0. Well, x to the 0 is 1, so we're not going to bother to write that x to the 0. And for our last term here, minus 7, if you want, you could think of this as really having an x to the 0 term next to it. If you were to multiply that down, you can see pretty quickly that that's just going to become 0. Alright, and of course we don't need to bother writing that plus 0. So our final answer, if we were to express it using positive exponents, would be minus 12 over x to the fourth, and then plus r2. So if it's multiple choice and you don't see negative powers, be prepared to have to switch it over. Let's look at another example. Okay, sometimes you're going to be given a function that needs to be simplified. So in this particular case, we can divide each term in the numerator by 2x. So if I were to rewrite this, what we really have here is 1/2 x plus 3/2, and then if I bring that x up, it becomes x to the negative 1. So from there, we can find our derivative by using our power rule. So we had to do some prep work first. By the way, you can't just go through and find the derivative of all three terms, top and bottom. So you would have to divide each of those terms up top by the term in the bottom. So we end up with 1/2, because this 1/2 x term is linear. So it should make sense to you that if it's a linear term, it's just going to be the number in front of x, because that's what the slope is. And a derivative is a slope. And then we'd have minus 3/2 x to the negative 2. So we can clean this up and write this as minus 3 over 2x squared. If it's multiple choice, you're more likely to see that. Okay, our last example here involves a function that is kind of nasty looking, and there is a good amount of prep work required before we can go through term by term and find our derivative. So with our first term here, we have the cube root of x squared. Well, we have to remember our exponent rules. This is the same as x to the 2/3. For our next term, this 2 over x to the negative 5. Once again, remember your exponent rules. When we bring up this x to the negative 5, this becomes 2x to the positive 5. And in the case of x plus 3, x minus 3, we can multiply this together. We can do FOIL, and we're going to end up with x squared minus 9. So you're going to have to sometimes do algebra before you could then find your derivative. So now we're ready to go through term by term and use our power rule. So notice our first term, we have a fractional power. So we're still going to multiply that fraction down. All right. Now when you subtract 1 here, if you need to, off to the side, you have 2/3. You're subtracting 1, which is really 3 over 3. So negative 1/3 is our new power for that term. Next one's pretty easy here, 10x to the 4th. And then, of course, these last two are not so bad either. So be on the lookout for algebra or prep work in general that is needed to get a function or a term in the form of x to some power. So x to some power is what we need in order to use our power rule.